Hello. Welcome to the Onboard Network System, ATA-46. Here we will address the Onboard Network System, ONS, what its main function is, and which components are part of this system. Let's start. The ONS can be described as the computer that stores cockpit system information. Also stores the LRU software, which has an interface with, and supports maintenance of some associated systems. The ONS works as a server for data collection, storage and analysis, helps us upload information, gives us fault reports, and allows us to monitor engine status and some of the ground tests. As for failure reports, some of the LRUs send fault information through DPC and the Digital Flight Data Acquisition Unit, DFDAU, to the Network File Server, NFS. We can see in the diagram the computers that are directly connected to the NFS via Ethernet, and all those that are part of the network. The onboard network system has the following components. First is the Network File Server, NFS. This new LRU is installed on the E42 rack, and uses the onboard maintenance function, OMF software to manage failures, software loads, perform ground tests, and other functions. It is important to mention that to load software, and make ground tests to the different aircraft systems, we should have the discrete signal of the air-ground relay active, thus confirming that we are on the ground. Remember, these functions are not allowed in flight. The second component is the maintenance byte panel, mentioned in ATA-31, for the Max Display System, MDS, and Maintenance Awareness System, MAS. However, this time we will talk about the section corresponding to ATA-46. The ground tests which enable onboard maintenance function to test the associated systems specific on the aircraft. This switch must be at normal position, or with the guard down. To activate it, the switch is moved to the enable position. It is important to emphasize that when finishing the tests that require its use, we must return it to the normal position. If we do not return the switch, we will have a maintenance light associated with the status message in the flight deck and we could cause a delay on dispatch. Also, this panel has an Ethernet connector that is used to connect the portable maintenance device, laptop, or tablet, exclusive for the 737-89, and gain access to the NFS. It is very important to note that any computer will not connect to the system. For it to work, it should always have the software required for the 737-89 installed. We still maintain the connection for the portable data loader, PDL, in case we want to upload software this way, as long as the computers were to upload software are associated with the selector on the P61. Now let's talk about the onboard maintenance function. This function is available only on ground. This function provides us with monitoring of aircraft failures, fault information processing, sending maintenance messages, monitoring the activity of cabin systems, and relates cockpit effects to maintenance messages. But, how do we get into the OMF? To enter this function, we use the Max Display System, or our portable device, such as the tablet or laptop. We have two ways. The first is through the Max Display System. We use our multifunction display panel, then enter System. The maintenance page be displayed, and then we enter the last option, which is the onboard maintenance. In this tab there are three main menus: line maintenance, extended maintenance, and other functions. Now we navigate in the three options that the OMF shows us. Let's start with line maintenance. Within the line maintenance menu we can find the following. Inbound flight deck effects, includes fault saved on the current leg with effects on the cockpit. We can find data such as maintenance messages, and at what flight stage it occurred in the description of the event. Existing flight deck shows us a list of active failures and gives us data such as the maintenance message, failure status, plus a description of the event. Ground tests, this selection shows an available list of detailed systems by ATA which have ground tests available. System configuration, here we find the part number of software installed and active in each LRU, with their respective ATA. Fault guidance, in this option we have a guide with the references of the maintenance manuals. Crew wireless access code, not available for our fleet. The ground test function, within the line maintenance option for outstation technicians, is very useful, because if they must perform any tests at the last minute and perform some deferrals, this section is the one they should use. Let's dig inside this maintenance option. Each ground test has 4 stages. First, test selection. we need to select the ATA, the type of test, and the specific test that we are going to perform. In the image you see the ATA that is selected, ATA 31, indicating system. As for the type of test, the selection shows this system test highlighted in green. Notice the cyan color shown by the operational test. This tells us that this test is not available for this system. Our specific test for this system would be DPC-1 Maintenance Light Test. Second, preconditions. Having the selection ready, we move on to continue, and the preconditions page will open. Here we find the description for each test and their instructions to follow. We must perform each step in order to have the necessary system configurations in each test, and that the test is performed correctly. We select to continue, and the next test page will open. Third, test. At this point it will shows us the name of the test we are performing, and start a sequence, describing what is happening at each stage of the test. Some conditions that might appear during the execution of the test and their meaning, are the following. Ready. As it appears, it tells us that all the prerequisites are met and the test is ready. At this point we can start the test. Select Start Test. We could also have the following conditions in other parts of the test, like inhibited. This message shows that there is something that does not allow the test to run and would have to be rechecked, if we have omitted a step, cannot operate, or cannot run the test. Operating appears when the test is already started. Passed, the test was successfully completed. Failed, the test failed. Stopped appears when we have stopped the test. We could expect to be enabled the following options within the test. Start Test. As we see, appears after the ready message and activates the OMF to start the test. Stop Test appears the moment the system is running the test, and you can stop the test when we select it. The stopped message appears. At this moment, the Operate Test Again option is enabled. It can also appear at the test passed or should be repeated. It also appears if the test failed, and you can also repeat it. At that time you will be shown the preconditions for that test again. Fourth, Post Condition. This selection shows the steps we need to take to return the aircraft to its normal configuration. It is very important to perform these steps and not leave the page without taking these prompts into account. Let's move on to the Extended Maintenance page. This option is very useful in stations if MOC or tech support requires feedback of any failure that has been reported. On this page, we have Present Leg. We find a list of faults that occurred in the last leg and can be shown by an ATA or by effect in cockpit, or as we know it, flight deck effect. Existing faults. This option shows us the active or present faults by an ATA or by flight deck effect. Within each selection we will find maintenance messages, system or LRU that detected the fault, date and time it happened, fault code, recommended action, and if it has a correlated message to any effect in the cockpit. Fault history. This option displays a list of faults stored in maintenance function on board memory. Let's look at the Other Functions menu. In this menu we will find the selection for Special Functions. This selection gives us access to the aircraft systems that have a single maintenance function or some special condition to activate and interact with that system. In this list, we have LRUs by ATA that has some special function. We can see ATA 32, ATA 49, ATA 71. Let's look at an example by entering the PSEU. We select ATA 32, which allows us to do two special functions: air, ground override, and reset latches. We have 4 steps to perform these special functions, which are 1. Selecting the system by ATA. In this step you select air ground override, then it will open the preconditions page. 2. Preconditions page. Here it will give us a brief description of what will happen after we press start function, the time it will take, and what you can do while this function is activated, and warns you to return to that page to return the aircraft to its normal settings. It will also warn of some effects on the aircraft, whether messages may appear, and gives us step-by-step warnings and instructions to enable special features. 3. Function. Indicates if the system is ready to select start function. If there are more specific options within the system, a dialog box will pop up so that you can choose the function you want to select, as shown in the image, in this case, for the PSEU in air mode. It shows you the 6 ways to do so, and depending on your assignment or requirement, you choose the one that best applies. 4. Post conditions. provides us with information to return the aircraft to its normal configuration.